Hello everyone, my name is Sayantanadu and I am going to present our work Tracing Historical Facts on a Timeline, a classification cum correct resolution approach. Our task can be defined as given a collection of timestamp documents, we would like to extract the most important facts and arrange them chronologically in a timeline. Now coming to our approach, we first assume that a sentence is the basic unit of a fact. That is, one sentence cannot contain the occurrence of multiple facts. So this is the overall system architecture of our approach. Now before going to the details of this architecture, let's start the discussion of the data preparation first. We primarily considered two historical corpora for our experiments. That's the collected works of Mahatma Gandhi and the collected works of Abraham Lincoln. Apart from that, we collected 140 major facts in India during the recent COVID-19 pandemic to determine the generalizability of our approach. Data annotations were carried out in two phases. First, we identified two major classes of historical facts, and three annotators were used independently to label each of the extracted sentences to three classes, that is, fact, demand, and others. One important point to note is that phase 1 annotations were not carried out for the COVID data. The table shows the example of the phase 1 annotation. In the second phase, the annotators were provided with sentences, the reference document, and the document's publication time. Based on the perception of the annotators, the sentences potentially referring to the same fact or demand required to be placed on the same cluster. For example, consider these two sentences coming from the same document and having similar atrocities and thus can be referred to the same cluster. And this table corresponds to the phase 2 annotations. Now coming to the details of the architecture. The first part of our architecture is the important sentence extraction, which tries to filter out the non-relevant sentences from the documents. Apart from the two simple baselines, we used fine-tuned BERT and GAN-BERT for the classification task. GAN-BERT is capable of utilizing unlabeled examples to improve the performances when the curated data is limited. Next, we performed fact coreference resolution to merge the sentences referring to the same fact or demand. Before applying coreference resolution directly to the sentences, we additionally extracted temporal information and generated knowledge-based tags from the sentence. Then we performed the coreference resolution in both the supervised and unsupervised manner. We used the hydral type tool to extract any explicit mention of the temporal expression from a sentence. We employ an ensemble of three different keyword extraction techniques on top of the search result achieved from the Google Search API to generate the tags. Now for the unsupervised methods, we use two different ways to vectorize the sentence, date and the tags and concatenate to get the final embeddings. Finally, we apply different clustering methods to determine the most appropriate clusters. For the supervised method, we first created mention pairs from the phase 2 annotated data by setting the coreference level to 1 if the sentence pair is contained in the same cluster and 0 otherwise. This is the architecture of the supervised model. A sentence, its corresponding action, tags, and date are passed through different layers and gets concatenated to generate a single mention representation. Two mention representations are then passed through an MLP to get the pairwise coreference score. Now coming to the first part of our result, we can see that the GAN-BERT clearly outperforms the other baselines for the sentence classification task. Note that this step was not conducted for the COVID-19 dataset. This is the result for fact coreference resolution. We can observe that the performance significantly improved after incorporating the tag embeddings for all the three datasets. So the key takeaways from our work can be listed as we used a two-step divide and conquer based approach to break down a complex NLP problem. We curated two historical datasets for the evaluation of such systems, and we introduced a novel tag creation for improving fact coreference resolution and showed the generalizability of our approach. Thank you for listening.